right, graphing radical functions. We're gonna feel like a superstar. And there actually is a reason I have this up here, shooting star. It's not just because I wanted to say superstar. Okay, first of all, this is actually, if you were in class, if you have questions, there are some that I know you probably have questions about. If you're watching this video and you've got questions, you know you can email me, and you can also put them in the discussion part of the lesson. Okay, just some vocab. I'm not worried about you knowing all of this, but basically just this. A radical function contains a radical expression. That's really it. They have to be a little more specific. With the independent variable in the radicand. So you've got a radical sign. Your variable has to be underneath. Okay? And then it says, when the radical is a square root, the function is called a square root function. When the radical is a cube root, the function is called a cube root function. And we've already been kind of using that terminology. So this is what they look like. Okay, so if I'm just graphing the square root of x, it looks like this. It looks like a shooting star. Okay, so starts at 0, 0, goes to 1, 1, and just keeps on going. Now the cube root function looks very similar to this. It's a little steeper, okay? But then it has that same thing going in this direction. So one thing to point out is my domain and my range for this are both above 0. You can see it's all in the first quadrant. But for this, okay, my domain and range are all real numbers. So it's this way and it's everything this way, because these are going to keep going out forever and get bigger forever. Okay, so they're going to ask you to graph some functions on the homework. And let's see. So this one, graph each function, identify the domain and range of each function. So what I did is I just did a table and I put it in my graphing calculator to get the answers. You could also put this in Desmos and it will give you the table. And I am really, really rounding. And I probably would have wanted to use some bigger numbers, but I just thought I would do this. So I've got 0, 0, 1 is 0.5, 2 is 0.7, 3 is 0.9, 4 is 1, and 5 is 1.1. So it looks just like a shooting star, but it's much more flat. It's and that is because we have a 1/4 here in front of it. So it's not growing as fast. It's only growing a quarter of as fast as it normally does. Okay, let me just check the time really quick. I forgot to set my alarm. Oh, okay, we're only at 3 minutes. Give me just 1 second here. Okay. All right, so let's do another one. This one is going to flip-flop, okay? It's going to be switched because it's a negative, right? So it's going to be flipped over the x-axis, and it's going to grow faster, okay? So again, I put this in my graphing calculator. You can put it in Desmos if you want. And because it's a cube root, I know that I can take I can use negative numbers. I totally forgot. In that last problem, the domain and range are both x is bigger than 0, or x is bigger than 0, and y is bigger than 0. Hopefully you saw that. Okay, so what I have here, this is 4.3, this is 3.830, -3, -3.8, negative 4.3. Okay, you're seeing a pattern, I hope. So negative 3 and 4, 1, 2, 3, 4, 4.3. Negative 2 and 3.8, 1, 2, 3.8. Negative 1 and 3, and then it goes clear down to 0. Then 1, negative 3, 2, negative 3.8, 3, negative 4.3. So this is coming in, it swoops way down like that and comes like that. So what is my, oh, that's kind of a yucky looking graph, oh well. What are my domain and range? Well, my domain, my x values, it's everything. I can put anything in here and I will get an answer. Okay, nothing is undefined. And going this way, this is going to go forever that way, this is going to go forever that way. So my domain and my range are both all real numbers. Okay, this should look familiar. Here we go again. We do this a lot in SM3 because we do these for all these different functions. So we did it for quadratics, we did it for absolute values. Okay, now we're going to do it with the square root function and the cube root function. Okay, and I think that is a good place to stop, and I will continue in the next video.